Okay, um, this is the second video on exponential functions, and then today I just want to kind of look at the math part of it, or not today, but in this video, look at the math properties. And so our exponential function is going to look like this, and we saw a few examples already in the last video. B is going to be where you start, so that's the starting point. Or if you want to get all mathy about it, you can call it the initial value. A is the rate, and we saw before that we had 1.1, which was 10% growth per year, meaning that after year one, you would have 1.1 times as much whatever you had the year before. We also saw an example where it was 1.04 in the infection. And then we saw the last example where we had what's called decay, and it was 0.9997. Okay, so those are some examples. Okay, and again with B, we had money at one point. B was our $2,400. B at the other point was 1,080 people for the infection problem. And then for the radioactive decay, it was 2 pounds. Okay. So I wanted to give you a sense of what A and B are. So hopefully these make sense. These are called parameters. We made sense of those. So what kind of questions have we been asking? We've been asking about things like domain. We've been asking about things, most recently, asymptotes, both vertical and horizontal. We've asked about zeros. We've asked about range. We've asked about intercepts, x and y. We've asked about increasing and decreasing. And we've asked about the graphs. And then about restrictions. Like, are there any values that we have to be worried about? We're going to see that B is going to be greater than 0. It's possible for it to be negative mathematically, but in applications, you see it's going to be a starting point. It's going to be something real. Even mathematically, A is always going to be greater than 0. We're going to have this possibility, or we're going to have this possibility. A equals 1 is positive, but it's a really boring function. And we'll do some examples. So we're going to see that. Okay. Now we're going to see that we get decreasing when A is less than 1. That was our radioactive problem. That was the decreasing. We saw that there was less radioactive plutonium every year, even by a very, very slight amount. And then you have increasing. That's going to be associated when A is greater than 1. And we saw that with money, the 10% growth, 1.1. Covered that up. I didn't mean to. And the infection rate, 1.04. Okay, so let's do an example, and we'll look at some of these questions. Okay, so I'm going to share the screen. I have a Desmos. I'm going to have to turn off a few things. Let's turn that off. And I'm going to take away this. Okay, and I have a function there. I'm going to turn that off, and I'm going to turn that off and take this away. Okay, so we have the function y equals 2 to the x. So here A is 2, and B is 1. So really what this is even though you wouldn't write it, B is equal to 1, A is equal to 2. Okay, so I'm just going to make that clear. Here, I might as well write it. B is equal to 1, and A is equal to 2, which means doubling. Okay, so we're going to do another example here, which is halving. And so before I graph things, maybe I'll start with the graph. Okay, so here's our graph, and I am going to, for now, hide all this. I'll come back to it. So I'm going to zoom out. And what do you notice about the graph? It goes up really, really quickly. It looks like it's getting vertical. It's not a vertical asymptote. Okay. Okay. But then you look on the left, and it seems like it is going to be an asymptote in the negative side only. It's kind of unusual. The graph is getting always closer and closer to 0, always above. I want to try to illustrate that behavior. I'm going to zoom in a bunch. And again, it goes to 0 really quickly. So let's go over closer to the origin. You see that you can see the values that when x is -1, I'm sorry, -1, -2, -2.5, 4, and so forth, you can see that y is getting very small very quickly. But notice, I'm going to zoom out a bit, but not too far. Notice that y is all, see, it's actually rounding to 0. It's not 0, it's rounding, but that's how close the function is to 0. Okay, but it's not actually 0, it's deceptive. Okay, okay. It's actually going to be a little bit bigger. And again, if we zoom in a little bit, you can see that it's just slightly above the over on the negative side, it's just slightly above the axis. Okay, probably beat that to death. Okay, so that's what the graph looks like, and what I want to do is get this back to normal. So let's zoom out just a little bit. So we have a nice normal window there. And I just kind of want to make the point, I like tables. I know that maybe not everybody does, but I think it's really useful. So I'm going to make a table here, and my y value here is going to be 2 to the x. Okay, so when x is 0, okay, 2 to the 0 is 0. When x is 1, you get 2. When x is 2, doubling, you get 4. Just throw in some random numbers. 2 to the 5th is 32. 2 to the 10th is a little bit over 1,000, and so forth. I'm going to just throw in 2 to the 20. A little bit over 1,000,000. 10 to the 6th is 1,000,000. Let's throw in 50. Things are getting pretty big. Let's throw in 100 just for yucks. Okay, you can see how quickly that graph is growing. It's just really growing quickly. Okay, so let's look at a couple of things about the graph, and I'm gonna just write them down here. That we see the domain. Oops, sorry, I didn't go. I want to write my comment. Thought I did it. There we go. The domain. If you look at it, let's look at the graph. It looks like we can plug in every number, and you can. There's no number you can't plug in. 2 to a negative power is a reciprocal. We'll look at that later. 2 to the positive power is a very big number. So our domain is going to be all reals. Our range, sorry, let me go back here. The range is going to be, if you look at it, we're always above the y-axis. Sorry, above the x-axis. So the range is going to be all positive numbers, 0 to infinity. Okay. We have a horizontal asymptote on the left side only. Okay. So as our x values approach minus infinity. What other questions did I have? Zeros. It's never 0. We see that from the range. So there's no x-intercept. And it's the y-intercept is 1. So we plug in 0, we get 2 to the 0, which is 1, and that's going to be our y-intercept. Okay. 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 So we know a few things about that. I'll talk about some other properties in a minute. I'm going to turn that one off. And let me spell that better. Okay. Now I'm going to turn on this graph. Y equals the 1/2 to the power. I'm going to turn those off. I don't want to plot those points. Notice that, well, this graph looks to be the opposite of what we just saw. And there's a reason for that. I'll go into it. But again, I'm going to turn it on, different colors. You can see I just swiveled it around. I just reflected across the x-axis, or y-axis, I'm sorry. So again, we're going to start writing stuff down here. So I'm going to turn this off. And let me add a comment just so you can see it. So y equals 1/2 to the t is a reflection across the y-axis of y equal 2 to the t. Oops. Okay. Oh yeah, I can't, yeah, because it's a comment, it doesn't make it an exponent. Okay. So let's fix that. Okay. If it's a reflection, it doesn't change the domain. So you notice it looks like we can plug in all values. So the domain is going to be all reals. Same range, just a reflection. Range is 0 minus infinity, 0 to infinity, I'm sorry. Same x-intercept. If I plug in 0, here I'll show you. Let's add a table. So I'm going to put here, and then, so it should be x. So I'm going to put a 0 here. You see over here, I get 1. So again, the y intercept is 0, 1. And there's no 0, so there's no x, no 0, so there's no x-intercept. Okay, what else do we have in there? Oh yeah, there's going to be looks like there's an asymptote on the right side. Again, it's a reflection. So we'll zoom out and you can see that. It gets closer and closer to 0. So I should have mentioned that here. The horizontal asymptote is y equals 0 for that function. This is here, y equals 2 to the x. Okay. And again, on the right side, you have a horizontal asymptote. Of y equals 0. Okay, so we know that. And right only, let's emphasize that. Now notice that this function here, let's go back a little bit. Let's back up. So I'm going to zoom in. Oops. Zoom out. Let's zoom in a little bit. Okay. If you look at the function, it looks like it's always decreasing, and that's going to happen. So this is always decreasing. And again, we'll talk about this. The book talks about it. Something that's always decreasing or increasing is what's called one-to-one. We mentioned that earlier. Now, if we go to look at y equals 2 to the x, let's turn it on. That's going to be always increasing. Okay. So we can go through these functions and do the kinds of things we did before. Again, this is a good review to think about some of those things. So that's basically what I wanted to do next, is give you a sense of what the graph looked like. Let's change a few times just to see, and you can get an idea. So here, there's both of them are on. So let's look at the graph of 1.1, which we looked at before. Same shape. It doesn't really change anything. It just doesn't increase as quickly. So here, let's compare that to y equals 2 to the t. You can see the difference. The one increases. So let's add a new one. So let's add a function y equals 3 to the x. You can guess what's going to happen. Let's give that a better color. Sorry. And I meant to make it a t, so let me do that. Use green. Use orange. Okay. Don't even really, I didn't turn it on. See, it's even steeper yet. So again, so you can see what happens to the graphs. As A gets bigger, the graphs get closer, get skinnier. Okay. Now down here, so that told us to give us some example what happens when A is greater than 1. This is what the graph looks like. Now when A is less than 1, here, let me turn all these off. When A is less than 1, here's an example. Let's do another example. Let's make us a number closer to 1. So we had that 0.9. Let's look at that. You can see it's the same shape. Let's zoom out a little bit. But it's fatter. It's going out a little bit more. It doesn't decrease quite as quick. Let's do another one that's small. Let's do y equals point 2. Okay, And you can see what that looks like. Again, let's zoom in. I encourage you to do this. You see, it looks like it decreases. You can just see the difference in shape. So as A gets closer to 0, this is going to be way closer to here. As A gets closer to 1, it's going to go way out